Okay, I'm going to shut this off because the competition's too stiff with the noise. This particular program, the only thing that's interesting about it is that there's a couple of things that I did with it. It's just a scene with 4 movies around the edges. In fact, believe it or not, it's the same film. I reversed it. I turned one of them backwards, and I left the other ones. So if you look upriver, you see, well, this is sort of up in the upriver direction right here, but you can't actually see it that way. Let's see, I'll go this way. This is the downriver version. You can see both of them are converging down that way, but on the upriver one, it's a little confusing. It looks like you can't tell what's going on. It's just too chaotic. It just doesn't really work very well. So basically, the bottom line is you really can't use the same video for all sides of the thing without fudging it a little bit. And also, you see it's bouncing up and down. That's because the person who took the video was holding the camera. And I don't know, they weren't in the water, but they were jumping around a little bit. The other thing that's interesting about this is look at these stone pillars right here, the columns. I'll go to this one over here. It seems to be more visible. When you look at these columns, instead of there being a straight line, like right here, right straight down here, which is what would happen if you had a 4-sided figure with just texture on it, you'd see a straight line here. I wanted it to be a little rougher. So what I did was, I took this thing into paint. I took the square one, the perfectly square one, into paint. And I took the red paintbrush, and I sort of ran along the edge of it and roughed it up a little bit. And that actually cut into the gray that was there, so that the image became a little bit, covered up. The edges of it get covered up. And then what I did is I brought it to X and View, and I said, make that red transparent. And what it did is it made the image with a rough edge here, where the red was, transparent out to the outer edge. So what you're seeing here really is the actual image is a little bit bigger than you see, but the red, which has been made transparent, is along the edge right here, and it roughed it up.
Now, by using that process, can you make certain objects out of the plane by just making part of it translucent, like a chair, perhaps?
You might be able to do that. You actually have to. There's a lot of people who've done a lot of work with that stuff. We can make chairs and stuff by the way. We can make that kind of stuff. The problem is that this course, I can only cover so much. And when you get into things like making designs and stuff like that, you can make them, but the problem is that when you make a design, it becomes a mathematical process. You have to figure out what kind of curve you want to use here, how you want to do this. You can make any shape, but you have to know whether you're working with a second-degree equation and all that kind of stuff. The only way to do it is to go to a program like Blender. Make it in Blender, bring it in, and you got it. Okay, because Blender, all you do is drag the stuff around. They do all the arithmetic. You just have to drag draw the thing however you want to draw it. If you're going to do it with the stuff we have, it can be done. In fact, maybe I should, I don't think I've uploaded them, but I have some programs I've experimented with that a little bit. I'll show you what they look like. Like I have a spinning top and weird shaped things that I just made up for. But it took some arithmetic and some figuring out to do it. That is the problem with this whole procedure. I didn't intend this ever to be a game creating situation. It's not really that. They have better programs for that. The only thing I had, this one is completely online, and it allows people, whatever you make in 3D can be online, which is that's the only advantage it has really. And you can code it pretty easily. You don't have to do a lot of detail. This one right here, I got another thing in here that aside from these stone columns, I have these wooden things. But let me go back to the Wabbit. See if I get the Wabbit program here. Where is the Wabbit? Sphere, house, circle, water flowing, abacus, Wabbit, right here. This is I think the Egyptian one used to be, but I think this one is the one that I ended up using, the 6-sided figure. Just all it is basically is a box with texture on all sides of it. But I used a bunch of these boxes. It takes a second here to get it up. There he is. So what you have here, there's nothing going on. I have a checkerboard floor, that's all. But the most interesting part of this is actually up here, is the structure. You can see right here you've got a beam like, and you got beams across here, and you got a beam across here, and this thing looks like a piece of plywood up on top, and then there's a beam across the middle. All those all of them are six-sided structures. They're stretched this way, stretch in two directions and leave it thin in the other. So it's the same thing, and all of them have textures on all the different edges, and that's all it is. There's nothing more. Then you have to assemble them, because that's the trick, is you have all these things are created at zero. You have to pull it out, turn it, pull it out, turn it, all that kind of stuff you have to do. But you can actually create structures like this. And then, if I were you, if I were creating something like this, if you wanted to move it, it would be hell, because you'd have to move each part of it. Okay, the ideal thing to do then would be to pick one part of it and make that the parent of all the other parts, and make a great big, then when you move that part, everything will go with it. So if you're going to move it around the screen, you've got a different place to.
Can you have, just curious, not really doing this in mind, but can you therefore have a parent object with as many hierarchical objects as you want, not just one?
They might have a 64 limit, but I doubt if they do. Maybe in the old days they would. I think today they just don't care.
So in a case like this, you could have like one wall be your object,
Yeah.
or the square, and then everything else is children of that object.
Right. They had
Your
I saw somebody made a snake out of a bunch of cylinders, and the head of the snake was the parent object, and each one was children. Yeah.
Okay.
And it worked pretty good. Of course, you have to be careful of that, because if the head of the snake moves, the whole snake goes like that. So you got to think that through a little bit.
Well, if you had to arranging your program, right?
Well, you have to.
Like you would only have to move the parent; it would translate everything with it.
Well, that's the problem. That's what I'm saying. That's the problem.
Yeah.
If you take the parent, the snake's like this, and you move the parent's head, the whole snake's going to go like that.
So
which is not something you'd want. Yeah. To get this to happen.
Not like the horse,
right?
Where it's galloping in a circle.
Yeah, you'd have to. What you'd have to do is, if you move the head this way, you'd have to, at the same frame, move the other thing this way, and the next one this way, and the next one that way. You'd have to move them all at once somehow. It would be hard, but somebody did it. I saw a snake that was done. It wasn't done in this language, but it done something similar, some similar language. These, by the way, the images here, all they are is pictures, and they're pictures on the inner side. Let me get here, go down up here. There are pictures on this side, but when you go to the outside of the building, it's a different picture. All it is, as I say, all these are is just six-sided figures. That's all they are. Okay, nothing special going on there.
So it's just a very, very thin.
Yeah, and I use WallMaker, but the only thing WallMaker does when you use it for something like this is it just gives you the mouse control. It doesn't give you anything else really, where you're standing and all that. But the images you have to put in manually. I didn't even put the floor in manual. I didn't put it in automatically. I put it in by hand. So there is no floor here really. By the way, you guys, I don't know if you know this now. If you hold the Alt key, you go up. And if you hold the space bar, you go down. Have you noticed that before?
Yep.
And you can go underneath the whole thing, get down below it. I don't have any barrier. I didn't create any barrier for the user not to go below the floor or above the ceiling. I didn't put any controls on it. The only thing is they can't go through the outer walls, but they can go anywhere else. And by the way, you can kill that if you want. I'll show you right now how to kill it.
I can go through on mine. In WallMaker, when I've been building mine, I have managed to walk through my outside walls, and I've even walked around my perimeter to make sure that when I was fighting like the spear and stuff, to make sure that I didn't screw up the coordinates. It wasn't like way out here.
Yeah, you got to be careful. By the way, when you get outside, if you go outside the wall, if you get out there some way, some mistake in the program, you can't move after that.
No, I've been able to walk. You know what I think?
No, once you get out there, you're dead.
No, because in mine I have like the floor, right, which is a JPEG image that I'm walking around on, and I have literally been able to, like a ghost, walk through my walls and even like walk around the perimeter.
That's because your walls. That's because your walls aren't on the outer edge. They're in.
Okay, that's why.
Yeah.
Then.
You can't go out beyond the outer edge.
Okay.
It's the end of the world. You go over the edge.
So I guess what I was doing was analogous to you're outside the rabbit house, but you're on your.
It is like this one here. I mean, this one here. This is made with WallMaker, but this floor right here is so small. You can go pretty far out of it. Okay, you can go quite a ways out. See, I'm way out there because the floor is just a little space. That's all.
Okay, but you're still within the coordinate.
Yeah, I'm locked into the WallMaker.
Okay, never mind. I was confused.
Never mind. Okay, anyway, that's it. So that's the rabbit one. What I want to do today is show you these little things that I've done, and I've never shown anybody before. Another thing is the circles. I didn't show you how to make a circle, but you can create one. It's possible to make just a circle. Now you might think, what do you want to do that for? Here's the reason why. If you make a cylinder, and you can say to the cylinder, put a 1 or a 0 or nothing, it will either put ends on it or will not put ends on it. If it put ends on it, what it does is it takes the texture of the side and flops it on the top. Now, you may remember I had a grocery store thing with cans. You remember that when they were stacked up? Well, the cans had tomato soup labels on them. I didn't want that to go on top. So I made the soup cans transparent on top and bottom. They were transparent. And then I put these circles on them that had the the top of a can, right? That kind of thing. And so basically, then they look correct. But then the question is, then what you gotta do is make them hierarchical, so they'll go with the can. When you move the can, the circles go with it, so it doesn't come apart. Does that make sense to you? So that way you've got the thing going. This thing right here, this nickel, could easily be a cylinder. I should have made it with a cylinder. I didn't. This was one of the first ones I did, so I didn't do it with a cylinder. If this is a cylinder, it would look like a pretty good nickel. But see the edges, it's too thin. There's no. What I did is there's only one circle, and I put a texture on it here. Then I put another circle, and I threw texture on the other side over here. So there's two circles with two textures. If you only have one circle, you're going to see the reverse texture on the other side, like that. So that's no good.
So
and
they're
so
hierarchical?
you have to move them apart. What?
So they're hierarchical in this case, so you see like the heads and tails of the plane?
Actually, I don't even think I made these hierarchical. Let's take a look if I did. I'm not even sure if I did. I probably moved them both concurrently or something, some dumb
Well,
thing like
that's what I
that.
mean, like, wouldn't it have to be a pair, one would have to be a child and one the parent?
Yeah, that would have been the right way to do it. I'm not even sure if I did. Let's see if what I did do. I'm kind of curious. It'll be down here. I'm going to get this thing a little bit bigger. We can't read it this way. Can you read it yet? Can you read that?
I can read it pretty well.
Are you okay?
It
Back
would
there?
actually still be nice to have it a little bigger though.
Let's see see how I did do that. I'm kind of curious. Nope, this circle. No, I didn't hierarchy. Let's see if I did it up above. I didn't do it there. See, I just put obverse and converse. Oh yeah, I did. There it is. Circle front, I added circle. There I did, right there. So in other words, I created circle front, circle back, and then I said add front to circle front, add circle back. So they're hierarchical. They're back to back like that, yeah.
How, you say there's a way to do this without having them hierarchical?
Yeah, you could.
By just having them at the same coordinates and
Yeah, you could have.
applying a rotation.
Yeah, you'd have to move them both away. That might be hard to do because they might rotate like that. I'd have to figure out how to do that.
You can't just have like, okay, my circle at XYZ and XYZ, and then
At the same spot, you wouldn't see them then. Say they'd overlap. They'd be like blurry. They go like this. They make a blurring thing. When you put two images over each other exactly, they don't.
They become
Yeah, it's jittery. It doesn't know which it's looking at, right? So you have to kind of separate them by a tiny space. And once you do that, the rotations are not the same anymore. If you say rotate 10 degrees, this one and this one, they'll both rotate 10 degrees on their axis, which is different.
So you don't have like a fraction of a unit in
No.
between either.
I should tell you this too. This computer language here has got some restrictions to it, which are not true in like OpenGL, which is the real computer languages, the things that are written in. They actually, in those languages, you can do a hierarchical thing in the program. You can say, freeze this thing and go to this thing over here and do something with it, and then come back to this and move this one, and that one won't move. And I mean, you can tell it explicitly what to move, and other things don't get involved. And that's very nice, but we don't have that in this language. We have to kind of go with what they have. And I mean, it's not bad. This is a good language. It's just some of the most sophisticated stuff. So we have to do it. We have to do it the way I did it, rather than just the way they might do it. So you could do that in their language. You could say, rotate around an axis that's a little ways away from me. So you could rotate like that. We can't do that. We have to rotate in the middle. That's what it does for us. We have no other way. So you have to use a trick on it. One thing I don't know if I've ever mentioned is this YXZ thing. Let me talk about that for a second. The order of rotation. when you say rotate over the x-axis, the y-axis, and the z-axis, well, if you do them in a different order, you're going to get different things that are going to happen. You're not going to get the same thing, because once, for example, if you suppose you say rotate over the x-axis, this amount right here, and then rotate over your y-axis, so you go like that. Okay. If you say rotate over your y-axis, and then rotate over the z-axis, you're going to be over here. You're in a different place entirely. So the thing is, the order in which you rotate is very important. What they do is they set up automatically. It's always x, y, z. It rotates over the x-axis, over the y-axis, over the z-axis. But if you want to do what we're doing, where the camera has the ability to look up and look down, and look left and right and so forth, and not get confused about, like, if you kept it x, y, and z, and you had the camera, if you left the rotation order the way it is, and you said to the camera, look to the right, and then look down, it actually would go over the x-axis first, and then it would go to the right, and you'd find yourself on some cockeyed angle. So in other words, it wouldn't work with x, y, z, because that freaks it out. What we need is y, x, z. In other words, look in this direction, and then look down or up. That makes perfect sense. If we say move down or up, in the opposite way, then you get a mess. So here's what happens. You guys didn't notice this, but all of the stuff when it runs the rendering function right here, it doesn't say it, but when it goes to render, it renders in the X, Y, Z order. That's the order it renders in, always. Okay, always X, Y, Z, because otherwise it wouldn't make any, what we try to do wouldn't make any sense. However, the camera, before it runs the camera down here, see it says camera rotation order is Y, X, Z. That's because in order for us to do things like look this way and then look up and then look down, we need that Y, X, Z. We need to go over Y first before we start looking up and down. So therefore, the camera's got a different order of rotation. But it doesn't affect us. I threw it in there early on, and I didn't think you'd ever look at it, and I just put it there to, maybe someday mention it, that's all. So that's one thing I should mention.
You also have like Z, X, Y, and all these, every combination thereof, or is it just X, Y, Z and Y, X, Z?
You just have X, Y, Z, that's all you have. There's only 3 dimensions to the world.
But can you have them in any order, because you have X, Y,
you can
Z.
put them in any order you want, but it's going to cause you can't tell what's going to happen. I mean, there's no natural way that you think about what will happen when this happens. In other words, if you say Y, X like that, just never mind the Z, Y, X, if you say I go over Y, okay, that means I'm turning this way.
Right.
And then when I look up or down, I'm going over X, this way. Okay, so Y, X in that order makes sense. If I did it differently, if I did the X one first, okay, I'd tilt this way, and then when I do the Y one, I'd go like that. I'd go up on my x-axis, I'd go up.
So the Z needs to be there as a controller.
Well, you take your axis with you, see. That's the hardest thing to get used to, is that when you turn over X, now your Y-axis is over here. It's not up here anymore, it's over here now.
And the Z-axis is like this.
Yeah, everything's freaking out. So that's why this thing is very important. By the way, anyway, I don't want to get this. There's a mathematical way of dealing with this, which is far better than what we're doing. But never mind. This is good enough. This is what we have to do for this deal. Okay. So in this particular operation down here, the only thing is I introduced this circle, which I hadn't shown you before, and it says you say whatever the name of the circle is. You say new make circle. That's the magic words, and then you give it a radius, and then you put a picture on it. And that's all it does. It puts a picture on the front and reverses it on the back. So that's how you make a circle in this language, which we never did before. We made everything else except that. Circles are handy for a lot of different things, and I just wanted to be sure you saw it before I get rid of it. Okay, this program, I think that's all this one does. There's some things in these programs I want to show you because they're very, very strange. Try to turn it down a little bit here so we can see what we got. It's fast too. Not. Okay. Sprites. I'm going to go down to the last ones to get for just for today because they contain stuff that I want to do. This one right here is just a typical, all it is a sphere. There's nothing else going on. It's a sphere, and it's a three-dimensional. If you go online and you say, give me a three-dimensional image, 360 image, it'll give you something that you can just plaster right onto a sphere and it fits perfectly. Now, and it shouldn't be any seam or anything. And this particular one here, it was an illustration of something that happens though. When they give you the sphere image, they're assuming this image is going to be plowed across the front of the sphere like that. That means if any words are on it, you'll be able to read it from the outside. Unfortunately, if you're making a world where inside's the important thing, like inside the submarine's where you want to be, all the words are going to be backwards. So here's what you have to do. There's only one way to solve it. You can't reverse it in the program. There's no way to do it because it's a 360-degree sphere. It's a weird thing. So what you do is you go to X in view and have it flip horizontally and then save it. And then it looks backwards when you look at it, but when you plaster it on the sphere and you look at it from inside, it's frontwards all of a sudden. So that's a problem that you have to solve. You cannot solve it by saying flip it math.pi, that's 180 degrees. That doesn't work because the sphere will flip, everything will be flipped to the other side, but they'll still be backwards on a sphere. It's a weird thing. It doesn't work like a plane. Okay. Anyway, that's something that you should know about. This one here is the lighthouse. There's nothing going on in the lighthouse. It's a three-dimensional, it's a sphere, and you can look down or up or roundabout or anything. Someone actually did all the work of taking a picture of this thing with a 360 camera. I don't know where this is, but it looks like a pretty dull place. There's no giant waves. There's nothing going on there.
It's pretty though.
Yeah, but then it has this thing right here. What is that?
A smoke detector? What else,
That's probably what that is. What is that cloth, though? It's kind of weird.
It's
I don't
a soft top versus a hard top. It's a convertible.
It's a convertible, right. But, and that light looks kind of primitive, too. I don't know what year this was made. It's got a dent in it, too. I don't know. I mean, the new ones, they must be using the new lighting, I hope, because it's much cheaper and better.
If it isn't already, it'll be LED within another couple of years.
It should have been, yeah, it should be LED now, but. Okay, so that's all that was that. This Coliseum here, same thing. It's just a giant spherical texture, and I just plastered it on, and that's what you get. I mean, these things are actually pretty good. They look very nice, and they're fast. They work very fast. Sometimes if you image, here's the only thing I've discovered about spheres, is you have to make the image, several hundred, 100 radius or something. I make it 100 radius anyway, and you can tell there's two things that happen. If the image is really, really precise, like it's like 1,000 by 500, it's big, a big image. You can put it out there at a couple of hundred, and it will still look pretty good. But if you get one that's 2,000 or 3,000, it's too big, and it'll be perfect when it gets up there. It'll look perfect, and it'll run fast too. But it takes a long time to get the thing downloaded, so there's a big problem. If you use a better picture, you're going to take a lot more time getting off the ground. So you should use 1,000 is about the optimal, I think. That's the one, 1,000 width, and usually the height is shorter, but that's about the optimal size. This one right here, I don't know what it is, but you can see it's not too bad. In fact, I could tell you what it is. Let's see how big this is out of curiosity. I think I just used what they had, or maybe I did make it smaller. I'll have to take a look here. It says 500 radius on the sphere. So if it's 500 radius, that thing has got a lot of detail. That's a pretty detailed picture, I think. It's a pretty good picture, I'd say. But 1,000 is about right. That's about as good as you want. If you're working with people who are in the city and they have super good connections, you can raise these numbers up by triple, and they'll still work because they're working at light speed. They're pretty fast. I don't know if you saw this one here. This is President Nixon's Oval Office days when he was there. This is his office. He had it made up to be something that looked like Thomas Jefferson's year or something. He was into that. And I just threw in these birds here. All they are is 3 groups of them, and they're, I think they're spherical, and I have one group going this way, and the other group going that way.
So they're not sprites, or are they sprites?
They're sprites.
Okay.
They're sprites, yeah. They're all the same. When you get real close to them, you can see they aren't doing anything. They're all just
they're two-dimensional, I guess.
just standing there looking dumb. Yeah, see, they're not doing very much. They're just, like that guy's just going around circles. Yeah, I have him rotating over the X, Y, and Z axis probably, which is kind of silly. But basically, you can sort of get the, I mean, have you ever seen, these birds do fly like that. They're kind of weird. They seem to weave between each other somehow. They're very weird looking little birds. They look like bees or something.
Did he have an affinity for
They make a bee
hummingbirds?
noise too, by the way. They do sound like bees.
Was that the sound you put in, or did you put in a hummingbird sound?
What?
Like, did you put in the bee buzzing?
The bee sound, yeah, I
versus
didn't. No, I didn't
hummingbirds?
throw it in. By the way, you guys seen that bee one I had? The bees flying around?
Yeah.
I had a woman that fainted in the class with that one time. I got to be careful of that. That one scares people. There's something scary about it, really.
Especially when you show it if you have like a lecture hall size class
Yeah, and the bees are all, yeah,
in the auditorium.
right. The circle, let me see, let me make sure I get everything here. Water flowing, flat circle.
Yeah.
The abacus, yeah. Let's talk about the abacus a little bit. There's a couple things in there brand new. The abacus, it demonstrates an interesting problem when you start to drag things. I'll show you what that is. So as soon as it comes up, it's got a lot of stuff in it. There it is. In this case right here, all is just this room with a bunch of math junk on the board. And this is the abacus. If you grab a hold of it with the left mouse, you can move stuff up. But you can see what the problem is. It isn't a very good system I'm using. What I'm saying is, check the distance that the mouse moves, and then move the abacus in the move the button in that direction. Whatever I'm pointing at, I say I'm pointing at that button. How much did I move the mouse? Then drag it to some percentage of the way, okay? The thing is, depending on the machine you're using, it goes a different distance because your mouse, it depends on the density of the screen. So if you're only going 20 pixels on one screen and 200 on the other, you can see the abacus is not going to know the difference. It's going to freak out. Now, you could fix that. You can say, what's the screen proportion of movement you have? You can do all the arithmetic, but it's just a lot of work, and I didn't do it. But the thing about this, which is the hard part, is this. I can move this vertically by moving vertical because every object in that room has the same Y direction. So if I move Y, it goes Y. Everything goes in the same direction. However, here's where the problem comes in. Supposing it was a tube like that, sideways, if I wanted to drag it sideways, well, if this was perfectly lined up so that this was the Y right here and this was the X right here, then I could grab a hold of this thing, I could drag it right along the X, it would work perfectly. But supposing the room was misoriented, it was different, like suppose you're in this direction right here, and now I want to move this thing along the X direction this way over here. Well, the X direction is no longer in that direction. The X direction is actually off that way, okay? And so there's where the problem is. In order to move something on the screen where the screen is going in an X or a Y direction like that, X direction, Y is always going to be the same. But in the X direction, what has to happen is you have to do a calculation of what does X really mean in the world. That's too much for this class. It's too much to do, and I didn't want to get into it because what it means is you have to kind of know some vectors and some blah, blah, blah. It was just too much. And so I said, okay, I'm going to have to give up with that idea. What you can do, however, which is a different thing, is you can click, here's the object I want to move, and click, this is where I want to move it to. See, whatever object you clicked on, it'll move it to that location. Now, the trouble there, of course, is if you say, click to the right, and you click on the back wall, and you want it to go in the middle of the room, that's not going to work. So you have this kind of difficult situation going. I don't know, I haven't got any good way to solve it. But so basically, you can't really move objects very easily. You can tell them where to go. You can tell it to move a certain amount of X and a certain amount of Z. You can say move to here, move to here. You can do that easily. But you can't just drag your mouse to do it because the mouse is always moving in the universal, because the camera's X direction is always to its right. which is not true for the objects on the screen. Their right is in a different place. So there's a little bit of problem there with that, and I don't know if there's an easy way to solve it or not. Quite honestly, I think doing dynamic things with this model the way it is now is a little bit on the hard side. But you know, there it is. That's what we have. As I say, all I did with it was exactly the same thing that we did with the blocks in the early programs we did. You just simply move the mouse a little bit, and then you say move the block proportionally that much. It's the same thing. And move the thing up, move it proportionally up that much. The trouble is different size screens, different proportion, it drags. It doesn't work the way you want it to. So when I lift this up here, in my computer at home, this thing goes right straight up with my mouse because it's got a different density of screen. Okay. Anyway, that's a kind of thing that you might come up against. This one right here is kind of interesting. This is new. It turns out that the point light that I showed you that we don't ever use for anything actually does cast shadows. It casts really good shadows too. It's very strong. But it also has the ability to be incandescent. You can make it really, really bright if you want to. Like right here, for example, I put one in front of this thing, and what normally is always the same color as the outer edges is now, as you can see, incandescent bright. It's really lit up really, really bright. And as this thing rotates, that thing facing us will always be that bright. It's not rotating with it, because what's happening there is whatever's pointed in the Z direction, there's a very bright light, spotted light on it, and it makes it bright. If you want to make the spot bigger, it's like a cone. You just pull the light back a little bit and it makes it bigger. Okay, pull it back more, it's going to make it bigger. So I pulled it back a little bit to make it bigger. At first I had it right against it. It was making a bright spot, just a little bright spot. And now you can see it's pretty incandescent. If you went inside this thing, you're in there, it whites out. That's because instead of just going 0 to 1, you can actually go to any limit you want. There's no limit. Apparently, I've tested limits. The only thing that happens is, at some point, I think around maybe 64 to 100, somewhere in there, it goes absolutely white, and then you can't get any more out of it. So in other words, the intensity, you can say intensity, point lockdown intensity equals up to, say, 100. Anything below that, it may be less than white, and it may not be. You have to get down at least into the 60s or 50s to get to have more color appear again. Yeah.
One thing I'm curious about is I get that, it makes your object glisten, so it appears almost, and putting the point light inside or whatever to make it like incandescent.
You can't do it, don't do that, yeah.
Oh, well then how is your moon orbiting the planet or your planet orbiting the star? How is it, as we're seeing it orbit,
okay,
having its lit side and its shadow side?
Okay, well the moon's further out than the light.
Mm-hmm.
Okay, it's a little bit further out.
It's over here.
Yeah, well see, here's what you have. You have the Venus, then you have the light right here, and then the planet, the moon's going around the side over here. So it's closer to you. You'll see the back side of it, you'll see the shadow.
So if the point light were the sun, the moon is getting some light from the sun.
Oh, yeah.
As the moon orbits the planet.
Light, and see, we're getting a strong shadow right there. There's a shadow right there. Yeah.
Se. Okay, now I get it.
And that's using Go X and Go Y to rotate it with that I showed you last
When
time.
you said incandescent, I thought that the planet itself became luminous, like when you went inside it.
No, by the way, that little moon that's going around is actually a sphere, just a little sphere, that's all. These guys look like spheres, but they're not.
They're sprites.
They're just sprites, and if you turn, they look like they're going to bounce into you,
Asteroids.
but they're just sprites. That's all they are, is just flat images. Okay, so it gives you a little bit of strange feeling there. I mean, when you think about that, I think there's 100,000 of them here.
Oh, wow.
That is an incredible amount of calculations. There's like three of these things. It's a huge amount, maybe even more than that.
Can a sprite, if you have too many of them, I know you said they aren't three-dimensional, but
Well,
if you put too many sprites in, will it bog down your machines?
Well, this is an old computer. Okay, to start with, it's a very old computer. It's running, it's capturing the screen, and it's running this three-dimensional program at the same time. So obviously, it's not taking up. I mean, it runs a little bit. These are running a little bit. If you look at them very closely, you see them bouncing, moving a little bit. Yeah, but considering the amount of work that's being done there, it isn't really It doesn't affect it that
So
much.
you could have 500 million of that in theory.
You try that and tell me what happens. Yeah, I think if you get to that many, I think it's gone. But don't forget, this isn't. There's a lot there, but this isn't a sphere full of them. You see, it's only a thin wall, but still that wall's got a lot of stuff on it. But it's just a thin wall of them right there. Yeah, I think there's 3. If I'm not mistaken, I think there's 3 groups that are running around. Anyway, so that's what that one does. Let's go to Noah here. The rabbit house. Go back to these. I think I touched on most of these before. We did all the stuff with the flying birds and all that stuff. We went to this one here. I don't know if there's anything here that I haven't talked about before. This one is very heavy on slow download. Got a lot of stuff in it, and so it takes a while for it to download.
Oh, this is like the force fire one.
Yeah, this is and it's pretty noisy too. I took the noise out, but there's a lot of noise. I think the noise of the trees with the wind in them, and the forest fire and the helicopters, and I think that waterfall has some noise too. So all those noises add up to a lot of noise. Just a very noisy type thing.
How did you do your circle then? It's like doing this kaleidoscope kind of effect.
Like that right there?
Yeah, because you can see it's
What
like...
you do is you get a picture of the flowers. You go to a paint program. You paint some red circles. You go to X and View, make those red circles transparent. And now what you have is a see-through sphere, little circles that you can see through. So when you plaster it on a sphere, yeah. And then I made another circle smaller, used the same image really, and made one of them rotate one way and the other one rotate the other way, and voila, there you have it. It looks kind of interesting, doesn't it? It's kind of an interesting thing.
It's interesting.
And you can see the possibilities are, I mean, you have, for example, not only do you have this, but you have the donut that you can work with. You can make holes in that donut too. You can make holes in anything. Yeah, you can put all kinds of stuff. You can create a kind of interesting, sort of sculptures of these things.
It's funny how just like, technically numbers are only 0 through 9. You have like a dozen different tools that you can compile in a million different ways.
Yeah, that's right. That's
to
what.
make a million different things.
Right. That's the whole idea of what you get. A bunch of things you can do, and you can make a lot of stuff out of it. I'm still not getting to the program I want to show you, the most important one here. I'll see if I can find it while I'm sitting around. I thought I had it right at my fingertips, but I don't seem to. This one right here. I think this is it. Yeah, this is it. Okay. The first, there is a way for you to have the program stall with an image in front of you, and then when it's ready to go, it'll release it and let you come to it, okay? I didn't incorporate that yet, and it's kind of hard to write, unfortunately. If you want to use this program next year, it'll be online as long as you want. Next year it'll be there. It's a little bit of, I have to change the fundamental program to do it, but basically I like that part because what you can say is, wait a few moments and your program will start, and then it clears automatically. Otherwise, what you have to do is what I've been doing is they read something, it stalls them a little bit, then they say, okay, go. And by that time, the thing hopefully is all ready to go.
Is this the thing where you made, I think you did show us where you had like not like your other screen, but you can click the thing to play the video and it like disappears, and then you have the...
Right here, I click on that thing.
Yeah.
And the program starts, right?
And then you press the
But-
silence button to stop it.
And then when you hit silence or something else, it brings it back again. Or if I hit this one over here, if I put this one over here, make it disappear, then if I hit this one, that one will come back. All I do is I simply look to see which one's playing and make all the others visible and make that one invisible. Not a big deal. But this isn't the program I was looking for. I got to look at it again. This one right here I talked about last time, which is using a video to produce the sound. Yeah, that's just a little bit of a thing. I only have 2 student projects up there. I have 4 projects, but I only got 2 of them up there so far. Jumping between lets you position the camera and program begin. Let's see what this one does here. I'm not sure if this is it or not. I'll take a look. Oh, this is just instructions on how to do it. Okay, sorry. Pardon? Lights, audio, no, we got all that. By the way, you should know those are here in last week's, because those are very handy to have. Hang on. Volume. Image. Stalls are used. This is it right here. This is the one I wanted to do. I changed this. It was previously different. Now it looks the same. It doesn't look any different. But it's only because of size difference here that makes it a little bit weird. Yeah. This is what it looks like. Basically, the first time what I did was I took the picture and I put it up there in a huge size. I said, okay, make it 2,000 wide, and I put it up there, which worked because most screens aren't that big anyway. But there's some screens have a little bit of edge showing. You can see what's going on behind the scenes. So then I said, okay, what I have to do is get this thing to cover 100% of its image, cover the screen 100%. So therefore, you can't see behind it in any way. So what I did is I changed this program. Let me show you what it looks like now, which originally just had the picture on it with a dimension of a width of 2,000. Oh yeah, here we go. 2,000. Get this up again. That looks like. Can you see that pretty good? Yes. Ah! Delay in the system.
Slow machine.
Come on. What are you doing? Okay. Okay, so what I have is I brought in this picture right here. Right here. See, it's, by the way, it's not under Graphics XX. It's above it. So I said, I have this image, and it's a zebra skin, and it's got that writing on it. Then I gave it an ID of skin, and I said its position, this is a style. I gave it a position absolute, left 0, top 0, which means it's locked in the upper left-hand corner, like that. And then what I did is I said, width is 2,000, okay? The problem with that is that's the one that goes off the edge of the screen and doesn't do it. So I've replaced that. Now here's what I've changed it to. Now what it says is width colon 100%, a percent sign, and then semicolon, then height colon 100%. And what that does is it starts in the upper left-hand corner and it runs at 100% across the window and then 100% down the window, so the picture exactly covers the entire window. So that way, if you when you want to block the screen, it'll block any screen that happens to be on at the time. So now, there's a thing about this I have to tell you. This using this 100% thing is kind of weird because if you're inside of a thing that's inside of something else, there's ways of doing that in HTML, which we haven't covered, but it's possible to get into a block that's inside of another block, in which case 100% to it means cover the whole block, not the whole screen. But we're not doing that. Everything we do is right out in the open. We just do the whole window. We don't have anything between the window and us. In other words, if you make a picture, there's only the picture of the window. There's no picture, block size window. There's nothing like that. So we don't have any of that stuff, which means that when you say 100%, it'll go right across the whole screen, which is what we want. But I'm just saying, if you ever take a course in HTML, you'll discover that that won't work in every program. It just works in ours. Okay? But that's the only thing I wanted to say. I got rid of that 2000 and changed it. I thought I had uploaded it, but I haven't. But that's the only change. It's just a picture, just like normal. Everything's normal, except that I said upper left 0, top 0, width 100%, and height 100%. And still, opacity equals 1, because that's how you block the background. And when they click a button, it goes up and changes the opacity to 0, and then you can see through it, and you can see everything going on. What's nice about it, another thing that happens when you make opacity 0, is that when you click the mouse on something in the scene, that front scene doesn't get in the way. When it disappears, it's out of your way, and you click on a ball or something, it works. Everything actually works. I worried about that in the beginning because I was worried that once you create a picture, even though you can't see it, it's still there, and if you click on it, it might interrupt the click and say, what did you hit, you know, something, but that doesn't turn out to be true. Okay, so there it is. We talked, all of our things we've done are in frame width and frame height. That means the entire window. It might happen that you might have something that you want to make in a smaller window where you can actually just have a little window of something and control it. You have words around it or whatever. All you have to do is change the frame width and frame height to divide by 2 to make it, if you divide both of these by 2, it's going to be a quarter the size of the window. Or divide it by any number you want, but use the same number because you want it to proportionally stay the same. You don't want it to reach any other proportion. Or you can multiply it by number 2. You can multiply it by 0.5 or whatever you want to do. Okay. But that's something that you might want to do. That's the kind of thing you could possibly want to. Okay, so out of here. Last thing here. Where is it?
It disappeared.
Here it is. Yeah. Okay, red, green, blue, yellow. That's not our three-dimensional world, is it? But it sort of is.
The red, blue, and green give the illusion of it being three-dimensional with the way it's lit, though.
What?
The way the color is graduated on 3 out of the 4, it's like the point light. It kind of, it appears incandescent and three-dimensional.
What I was doing here, if you look at this thing, all it is just it's not a three-dimensional thing at all. But notice this thing, this key hit thing here. That was the idea, is to get used to the idea if you say, if you hit that key, do this. If you hit this key, do that. Because we did all that stuff before we actually get into 3D. But these are very handy things to do. Oh, there's something else I discovered. If you wanted to talk to your program, I have built programs that three-dimensional programs you can talk to. You can say spin, stop spin, move, or go 50, go, you know. In fact, I think I can get one for you right now. Let's bring it up. It's called there's a program out there called Blocks, BLOCKS, .html. And that has a series of programs you can run from it. I mean, should it run? There it is right there. These programs are all programs that will run, that are set up to go. It's set up for to work with a webcam too, but here, for example, if you go to Blocks, supposing you wanted to do a person-to-person, you wanted to communicate with somebody. Okay, so I hit P2P here. I just clicked on P2P. And what it does is it says if you want to communicate with somebody, set up a word that's your secret word that will connect to them, okay? Like at home now, I have my camera running right now, and I set it up, and the word I use is yard. And it's already running, so instead of saying start new call, I go over here to join, and you should see my backyard. If it works, you'll see my backyard. That's me. And there's my backyard. See? Now, and all you have to do is go to Blocks and hit that. Now, I wish I could give you the code for it, but here's the trouble. It won't run in this Chrome because Chrome doesn't like this stuff unless it's running on a secure socket. So what it is, I played a little trick. I have this thing where you press PP, it jumps over to a secure socket and runs the program. So even though Blocks is just a normal program, it just links to this other one and it runs. So that there.
You Firefox and also like the
thing. In Firefox too.
But I mean, if you ran it in Firefox and you need it to jump over a secure socket layer, like you mentioned. that Firefox does.
No, you can't, there's no way to do that. Jump from Chrome to Firefox?
Could you have both of these running in Firefox to avoid needing a secure pocket layer because Firefox?
Oh, yes. See this title? You can read it right here. Once you hit P2P, it's to this location right here. See, that's the official. See, it says HTTPS, and it's got this special code in here. If you wanted to just type this into your machine, it'll go right to the program in Firefox. Okay, like I'll do it. So I'm going to select this thing here. I think I'm selecting it. Okay, so I select, and I'm going to quit the program, and I'll open up in Firefox and see what happens. It'll do it like that, yeah. Firefox is actually pretty good. The only thing Firefox doesn't do is all that nice three-dimensional stuff. It doesn't cover everything for us.
It doesn't have the tooling to do like WallMaker then?
It doesn't have sound, and it does have sound, but it doesn't have it.
So
Yeah, some of the stuff we use, it doesn't.
Something in WallMaker in Firefox then, per se, or you would at least experience extreme difficulty.
Well, from time to time, they catch up with each other. It's a constant change. It's hard to.
One is surpassing the other.
I knew, for example, some of the things that the Chrome, like that thing you came across, Chrome actually fails at its own thing, and Explorer handles it. What do you make of that? I don't know.
If Internet Explorer does it, I don't know.
Explorer is actually, what's the new thing they have? Edge or something like that? It's called Edge.
I'm not sure.
Windows 10, but
It's much more sophisticated. There's a start page. I don't want that. I want my thing. Try it again. Doesn't seem to like this for some reason. Okay,
just be that your
let's
machine
try the other
slow.
thing. Dartworks.com. Let's go to blocks, see what happens. Okay, now I'll try P2P, see what happens then. I guess that kind of showed me I couldn't just type it in. This thing doesn't seem to be cooperating here for some reason.
Could just be that your machine is running slow because it's also screencasting.
It says connecting. See what happens. If it loses the connecting thing, then we know we're in trouble. It's cross-eyed.
It's trying to contact the website.
I like to think of this thing as being like two different eyes going like that. There's only one. They have the other eye shut.
Mac had it really aptly named, like the beach ball of doom when the computer was thinking, or like the clock of doom is their
The clock of
loading
doom.
symbol.
This doesn't seem to be working very well. As you can see, it doesn't work anywhere near as well as the other program did. So there it goes. I don't know. Try it at home. I don't know if it works, but it doesn't work here for whatever reason. Anyway, that's pretty much what I wanted to show you. I covered most of the things. Next week, I'll be sort of winding it up. We'll get down to what we have to. We have to get it by next Thursday. I'm supposed to get all of the. I only got 3 so far or something, so we'll see what happens. But I should get all of the projects. That's it. If you have any questions, I'm going to be here for a while, so just if you have any questions, just fire away. I'll be here. Okay.